Hello, welcome to Accounting Hub. I'm Professor George Scarpin, PhD in Accounting, and our topic today is how to perform a hypothesis test using the t distribution. Remember, we use a t distribution, that is the most common here, when we don't know the population standard deviation. That is what we have in real life. So, a hypothesis test regarding the population mean is based on the assumption that the sample mean is approximately normally distributed, especially if the sample is greater than 30, 35. That is our central limit theorem. And by the way, we have a video about that. If you want to know more about this topic, the video is in our video description. So assume that the population means is the hypothesized value of the population mean in the new hypothesis. And the test statistic, t, number of degrees of freedom, and the degrees of freedom is the n, the size of the sample minus 1. So it is the sample mean minus population mean divided by sample standard deviation divided by the root square of the sample size. Don't worry, we have a copy paste of all of our formulas in our Excel file. Then find the p-value, the likelihood of observing a sample mean that is at least as extreme as the one derived from the sample, assuming the null hypothesis is true. Huge math formula, but we will go on Excel. And this depends on the specification in the alternative. So, remember that a type 1 error, and by the way, we also have a video about errors. The video is also in our video description. Occurs when we reject the null hypothesis when it's actually true. We define the allowed probability of making a type 1 error as alpha. So we compare alpha with the p-value or the critical value, or alpha with p-value, we will see that later. And we refer to 100 alpha percent as the significant level. And the p-value, on the other hand, is referred to as the observed probability of making a type 1 error. Use the p-value to make the decision. That is the easiest way. Reject the null hypothesis if the p-value is lower than alpha. Do not reject if the null hypothesis if the p-value is greater or equal alpha usually. We generally choose a value for alpha before implementing a hypothesis test. Care must be exercised in choosing alpha because important decisions are often based on the results of a hypothesis test. Most hypothesis tests are conducted using a significance level of 1, 5, or 10%, using alpha 0.01, 0.05, or 0.10, respectively. We will see that much better on our Excel file. And the conclusion to reject or fail to reject, so we don't accept, reject or fail to reject, is based on comparing the value of the test statistic to a critical value or comparing alpha and the p-value. From the sampling distribution of the test statistic when the null hypothesis is true and the chosen level of significance alpha. So the sampling distribution of the test statistic is usually the normal distribution, t distribution, or some other well-known distribution. T distribution is the one that we are working with, one with most of the tests work with. And the critical value divides the sampling distribution into two parts, rejection region and a non-rejection region. If the test statistic falls into the rejection region, we reject the null hypothesis, otherwise we fail to reject it. So here, one tail test or two tail tests. So here, parameter greater or equal a constant, H1, parameter is lower than constant. That is here. So lower one tail test. If our numbers comes here, we reject the null hypothesis. So yes, our parameter is lower than the constant. On the other hand, we want to check if it is greater. So we reject the null hypothesis lower or equal. It is this one tail. Or equal and different, we go to two tail test, and then alpha divided by 2 on both sides. For a one tail test, if H1 is stated as lower than, the rejection region is the lower tail, greater than is upper tail, and then just think of the inequality as an arrow pointing to the proper tail direction. And then how do we do that on Excel? We have these formulas for the critical value. And then here the critical value, depending on how we create our hypothesis. If it is a lower tail test, negative t dot inv, and then upper level. And why negative? Because lower tail, we are here, the negative side of our chart. Upper, it is positive, so positive. And two tail, either we use this first formula, that is this one, alpha divided by 2, that is alpha divided by 2, or the t in 2t alpha instead of 1 minus alpha, n minus 1. That is the degrees of freedom. N size of our sample minus 1. For the p-value, so this is one way of finding our, or to conclude if we will reject or not, or comparing the p-value for lower one-tail test, upper one-tail test, and two-tail test. So, okay, let's go to our Excel file, and then let's delete all of these, or let's not delete, let's copy and paste here, and then we can double check if our numbers are right or wrong. So, okay, the dean at a large university wonders if students at the university study less than the national average of 24 hours per week. Okay, we have a national average. So, okay, if the students stud less than the national average. So the null hypothesis is the opposite, greater or equal to 24. That is the constant here, that is the average or the population mean. And the H1 if it is lower than 24. So here what we have, our test here is lower tail test. So this is our test. Population mean 24. The dean randomly selects 35 students. So yes, we can use the central limit theorem, the CLT, and as the average study time per week in hours, because here we are hours. From their responses, the dean calculates a sample mean of 20 hours and a sample standard deviation of 8 hours. And then 35 is the student sample. So, okay, and let's consider first an alpha 0.05. So, if we go back to our Excel here, to our PowerPoint, sorry. Here, the significance level of 5%. That means that our numbers will be right in 95% of the time. So, okay, first we need to find the t, and there is, at least I couldn't find a formula or an Excel function for t, so we need to do it. So, equal the difference of the means. So, sample mean minus population mean divided by standard deviation, sample standard deviation, divided by square root SQRT of the sample size. So here the t is negative 2.95. Okay, and why it's negative? Because we are testing lower than. So our sample mean is lower than sample size. If our sample mean would be higher, it doesn't make sense to test a lower. Okay, so kind of just be reasonable here. And then, okay, let's test the first way based on critical value. So the critical value on lower tail test, that is what we want. Negative t invert. So let's come here, negative formulas, insert function. Let's go on all, and then t dot inf. Go t dot inf, what we want. So probability, 1 minus alpha. So 1 minus alpha, 0.05. And then degrees of freedom, remember, sample size minus 1. 1.69. And then, do we reject or fail to reject? Okay, we compare both. Critical value is lower than t, so we reject. But never type it. We are comparing two numbers, so classical if formula. So if critical value is, or if t is lower than the critical value, then we reject. Otherwise, we fail to reject. Reject, and let's consider that this t would be 0. Fail to reject. Oh, no. Better. But, okay. Okay. So, the first way to check it. So this is our final answer. We would reject H0. So yes, on this university, the students study less than the national average. However, how do we do the p-value? So the p-value, and how do we do the p-value for the one test tail? T-dist. So let's go here, formula, insert function, all T-dist. A lot of T-dist here. T-dist. Whoops. T-dot-dist. That is the one that we want. So the return left tail t and x is the t. That is what we have here. Degrees of freedom. Remember, size. Sample size minus 1. And if it is cumulative or not, yes, it is cumulative because it is from 0 until t. So it is true. And here, 0.028. And by the way, do you want to find the 0.05 here? Minus 1.6509, 0.05. So if t is equal to the critical value, the alpha or the p-value would be the same as alpha. But let's go back. So what is our if formula here? If p-value is lower than alpha, and that is how, and we use p-value in a lot of techniques such as regression and a lot of other tests, but especially regression. When we are comparing means, also we use it. So we will be talking a lot about p-values. So, oops, come on, reject, otherwise fail to reject. So reject, and we are good. So here we reject the null hypothesis that the students study at least the national average. So yes, we can assume that this is rejected. So the students studied less than national average. But again, we cannot prove anything on hypothesis test. But we found strongly evidence that yes, they study less than the national average. However, let's do some instead of alpha 0.05, let's go 0.01, that is the most restrictive. So here on 0.05, we would be right in 90% of the times. 0.01, we want to be right in 99% of the times. Well, we still reject it. So we still reject both on 0.05 and 0.01. However, if the sample mean is 22, well, now we fail to reject. Or 21. We fail to reject on 0.01. However, we reject on 0.05. So the lower the alpha, the harder is to reject a hypothesis. However, if the alpha is 0.10, and let's go on the, here we also reject it, but if it is 24, we fail to reject. Okay, and then 23, we fail, or 22, we reject. But if we go on 0.05, we fail to reject. So the greater the alpha is, it's easier to reject the null hypothesis. The lower, it's harder. But let's save it with our original numbers here. Okay, guys, thank you so much. This is not easy. I will not lie to you telling you, oh, that is easy, you can do good. So watch this video as many times you need. Okay, guys, thank you so much. Have a very nice day and God bless you.